Number 1, what are the mole fractions of phosphoric acid and water in a solution that is 14.5 grams of phosphoric acid in 125 grams of water? As mentioned before, most of the time when you see grams in here, you will need to convert to moles, and this is one of those times. So you need to find the molar mass of phosphoric acid, which you can do by looking up the values for each atom on the periodic table and adding them together. And you should get 1.48 moles of phosphoric acid. And then for water, again, the molar mass. And the molar mass for water you might want to commit to memory because this is something that you will use a lot. So for moles of water, you should get 6.94. Then we need to find the total moles. So to find the total moles, you add up the moles that you just found in order to get 8.42 moles in total. So to find the mole fraction of phosphoric acid, I'll take the moles of phosphoric acid and divide it by the total number of moles in solution. And I get a value of 0.176. Now to find the mole fraction of water, I can either take 1 minus my phosphoric acid mole fraction, or I can take the number of moles of water and divide it by the total number of moles, which should come out very close, if not exactly, to the other answer. So from here on in, I'm going to use this method in order to find the solvent mole fraction. Number 2, what are the mole fractions of nitric acid and water in a concentrated solution of nitric acid? Now they define that a concentrated solution of nitric acid is 68.0% nitric by mass. So that means there are 68.0 grams of nitric acid when there are 100 grams of solution. Now, in order to get 100 grams of solution, and if we already have 68 grams of nitric acid, then that means we're left with 32 grams of water. So I think that's the tricky part for this particular question. Once you have that, calculating the mole fraction should be fairly easy. So you need the molar mass of nitric acid. I get 63.01. And the molar mass of water. So the number of moles of nitric acid, I have 1.08 moles of acid. And I have 1.776 moles of water. Now that gives me a total mole of 2.8, let's see if I can write, 2.856. So to find the mole fraction of nitric acid, I take the moles of nitric acid and divide it by my total moles. And I get a fraction of 0.378. The mole fraction of water is then 1 minus 0.378, which I find to be 0.622. Number 3, we're going to calculate some more mole fractions here. We'll start with 583 grams of sulfuric acid. Convert that to moles. And we have 1.50 kilograms, or 1.50 times 10 to the third grams of water. And I get 83.2 moles of water. So my total moles is 89.14. I'm leaving the extra digit to avoid rounding error. So then my mole fraction of sulfuric acid is going to be 5.94 divided by 89.14, which is 0.0666. We do need 3 sig figs. We started with 3 sig figs in both of our measured quantities. So the mole fraction of water is then 1 minus this value. So I get a 0.933. For the second part of 3, we'll take our 0.86 grams of sodium chloride and, as before, convert to moles using the molar mass. And then we'll take our 100 with 3 sig figs grams of water and convert that to moles, again, using the molar mass. We have our total number of moles. I get 5.56. It's hard to say it's anything else. So the mole fraction of sodium chloride is going to be the moles of sodium chloride divided by the total number of moles found, and I get a mole fraction of 2.64 times 10 to the negative third. So this is a mostly water solution, and the water has a mole fraction of 0.998. For the third one, now we have codeine and ethanol. Codeine is a larger molecule. It's C18H21NO3. So look up on the periodic table. For each carbon, you have 12.01. So you're going to take that 12.01 and multiply it by 18. Then add that to 21 times 1.01 for hydrogen. Your nitrogen has a mass of 14, and then you have 3 oxygens. Remember, oxygen is 16.00. You're going to multiply that by 3. When you add all of that together, you should have a molar mass of 299.37, or very close to it. So you can convert this into moles, and I get 0.156 moles of codeine. And then I have ethanol as well, so 125.5 grams of ethanol. Again, calculate that molar mass by looking at the periodic table. You should have a periodic table with every one of your quizzes. So 46.07 grams is the molar mass I find there for 2.72 moles of ethanol. Add these two items together, you should get a total mole value of 2.876. Now I'm using the extra digits on purpose. So the mole fraction of codeine that I find is 0.156 divided by this 2.876. And I get a mole fraction of 0.0542. Now that makes the mole fraction of ethanol 0.946. And for the last part of number 3, I have 25 grams of iodine, and I'm going to convert that into moles. Remember, iodine is a diatomic atom, or a diatomic molecule, so I need to take the molar mass of one iodine atom and multiply it by 2. So I get 0.0985 moles of iodine. Now for 125 grams of ethanol, and I found the molar mass of ethanol in the previous problem, I have 2.71 moles of ethanol. So that gives me a total of 2.81 moles. So for my mole fraction of iodine, I have 0.0985 divided by my total moles, 2.81, in order to give me 0.035 as my mole fraction of iodine. So that makes my mole fraction of ethanol 1 minus this value, So I get 0.9625. And just to show you how this works, so my mole fraction of ethanol, I'm just going to review this real quick, is 1 minus the mole fraction of iodine. And that's where I get my 0.965. I think I put a 25. That's incorrect. Now, if we were to calculate the mole fraction of ethanol just by itself, I would take the moles of ethanol and divide it by the total moles. And when I do that, I get 0.964. So you see, variation in this last digit, I'm not going to worry about. You see, it's very close. So we can use this 1 minus as a shortcut.